Sure, we'll kick off the webinar now. I am one of your presenters, Donald O'Malley from Kaizen PLM. I am joined by Tobias Kattner of Janus Engineering. Today we will run through utilising NXCAM and Productivity Plus for on-machine probing, in-process control, decision making and adaptive programming. Just to give you a background on Kaizen PLM, we are an Irish-based Siemens Digital Industries software gold partner. We provide solutions and support solutions for CAD, CAM, CAE analysis, virtual commissioning, technomatics, MCD, additive manufacturing, Teamcenter, Polarian, Mendix and Keyshot. We are a specialist partner for the additive manufacturing portfolio from Siemens for the UK and Ireland. We also provide 3D scanning services, so we can provide a service of scanning components for you, or we can provide the hardware for such scanning. And to speak a bit about Janus Engineering, they're Siemens Digital Industries smart partner. They have offices across Europe and one in the USA. They look after solutions for CAD, CAM and PLM. They also provide various NXCAM plugins to enhance capability and streamline processes, all within the NX environment. As you can see on the slide here, the Siemens software portfolio offers a lot more than just CAD. Siemens are the largest engineering software company in the world and offer everything from manufacturing execution systems to electronic design and low-code app development platforms. As we can see on the top left for mechanical design, we have NX, Solid Edge, FiberSim, SynchroFit, MasterTrim, Somatic IT, R&D. There's within NX, obviously we have the CAD CAM. We also have simulation analysis tools within that, and the same as with Solid Edge. Under the software portfolio, there's solutions for a vast array of applications for electronic design automation, software delivery, simulation and test, performance analytics, manufacturing operations, automation, manufacturing planning, and all these can be made work together in collaboration using Teamcenter and MindSphere. So why would you use NXCAM? The main objective for a manufacturing company, regardless of the industry, is increasing throughput. That's one of the key competitive pressures. You can increase throughput by shortening machining cycles, faster setups, and reducing machine downtime. Meeting the quality standards is critical. Consistently achieving high quality requires precise machining, better finish, and using the best practices to achieve repeatability, which is another element of quality. As you compete, you want to look at new technologies that will open up new business opportunities. Achieving these objectives is a challenge for many manufacturers. One of the main reasons are inefficient processes which they have in place. Specifically to production parts manufacturing, the typical situation is some of the pain points like complex machine tools or optimized NC programs will be solved by using NXCAM, as we offer a complete solution. This means we do have a wide range of modules available, including mill turn support or wire EDM. Many people understand how to automate the process by using FBM, which is our feature-based machining module. As many competition systems also offer a similar solution, but NXCAM also addresses automation inside the setup process or customized templates to also automate any interactive programming. Even with FBM, We are ahead of other systems as we can react on PMI tolerance information coming out of various CAD systems. So we're talking not only about NX CAM. If it is coming to the question how much time a customer can save using this approach, we can say, as an example, by using feature-based machining, you'll reduce your programming time by 60%, and because you're using standards, you'll get a constant quality. As the automation approach is simple to use, you can see new users will develop the same high-quality output as experienced users. Industry-specific solutions. NX CAM system has been adapted across many industries, delivering proven manufacturing capability. Mold and die typically combining techniques such as 3-axis high-speed milling of hard tool steels with more prismatic parts needed for tool bases. Production machining covers general machining of prismatic parts such as components often used in the machinery industry or complex parts. Use cases typically associated with aerospace, power generation and medical devices. Cases where it's more usual to see continuous 5-axis machining. As can be seen in the slide here, NX CAM has the capability to program any job regardless of the machine. High-speed machining methods, 2.5-axis milling, 3-axis milling, 5-axis milling, turbo machinery milling, fixed plane and hybrid additive manufacturing, multifunction machining, 2- and 4-axis wire EDM, hole making, turning, robotic machining, extensive tool libraries, efficient shop floor documents, on-machine probing, post-processing, machine tool NC code simulation, and CMM inspection programming. The latest CAD technology in NX enables the NC programmer to rapidly prepare part models, including third-party CAD models. NX also provides additional manufacturing applications such as tool and fixture design. The 3D model moves seamlessly between applications without data translation. The CAD CAM CNC process chain supports the core machining solution. Many companies need additional applications and other equipment to complete their part manufacturing process. So that your CAD and CAM is fully integrated within one another. It's just a case of switching the application. So if you're working with third-party CAD models, you can use the synchronous modeling for making a number of CAD changes very easily, and in some cases it's actually easier to make the design changes within NX using synchronous modeling than if you were to do it in its native format. Siemens provides a complete part manufacturing solution from planning to production. Connecting NX to Teamcenter software for data and process management establishes a basis for an extended part manufacturing solution. All types of data from 3D part models to setup sheets, tool lists, and CNC output files can be fully managed. Shop floor applications are available, including distributed numerical control, to connect the Teamcenter managed data directly to machine tools. Shop floor data management solutions can use plan data in interfaces to equipment such as tool presetters. This diagram represents our view of a complete part manufacturing solution. The advantages: integrated software applications and equipment. NX provides a complete suite of CAD, CAM, CAE and CMM programming applications all in one system to support your full range manufacturing engineering needs. Data and process management. Teamcenter provides data and process management that allows manufacturing, engineering and production teams to work together using a single source of information. This helps you eliminate the need for multiple databases. Reuse proven methods, manage tooling and connect the work package directly to the point of execution. Connect planning to production. You can access manufacturing planning data directly from the shop floor by connecting PLM to production systems. By connecting Team Center and shop floor, you can send machining data and tool list information directly to CNC machines. With NX-CAM, you get a full range of NX programming capabilities to efficiently manufacture prismatic parts used almost any industry, including machinery, automotive and energy industries. You can program prismatic parts twice as fast with volume-based milling. Select floors and walls and then let NX-CAM calculate the machining volume to create smart tool paths. Because NX tracks and displays the remaining material after each operation, you can easily create tool paths that efficiently cut leftover volumes. NX provides a simple way to program parts that require multiple setups. It automatically tracks the in-process workpiece across the entire process so that repositioning moves are kept safe, machining operations are optimized, and error cuts are minimized. With NX, you only need one system to drive milling, drilling, turning, mill turn, and wire EDM machines. The tracking of the in-process workpiece makes programming fast and simple, even when the part is transferred from machine to machine. Manufacturing Resource Library, or MRL, is a Team Center application that lets you manage all of your manufacturing resources. With MRL, you can assemble your cutting tools using the components stored in a fully classified library. MRL can be accessed directly from NX-CAM, so you can search and retrieve the tools needed for NC programming. You can automate programming for standard features, part families, and even multiple parts arranged in fixtures. Program a single part and copy it to all the workpieces. The collision-free toolpaths are associative, which lets you adjust a single operation, and the system will automatically update all the toolpaths. There's no need for extra third-party machine tool simulation software to check the toolpaths. You can validate your programs directly inside NX-CAM. Use integrated G-code driven simulation to accurately represent how your machine will actually perform on the shop floor. A 3D model of the machine with the part, fixtures and tooling moves according to the post-processed NC program. The integrated CAD capabilities let you design features and clamping devices. The Knowledge Reuse Library enables you to easily access your standard parts for setups. By using the assembly capabilities, you can quickly position parts in context. The setup configurations can be easily shared with the shop floor via conventional drawings or 3D viewer technology. NX-CAM automatically produces shop documentation that includes both tooling information and operation sheets that you can easily configure. You can manage all of your manufacturing data, including 3D part models, resources, and NC programs in Team Center. This enables the entire team, including the production staff, to use the same source of data. Using Shop Floor Connect, you can access and review the revision control manufacturing data in Team Center. The correct work package can be sent to production, ensuring that the right data is used to machine parts on the shop floor. By digitalizing your manufacturing process, you can unite the virtual and physical worlds of production. The established digital thread that connects people, equipment, and the entire process helps you optimize the operations to deliver high-quality parts. NX offers a complete range of machining capabilities for the latest multifunction machines that support simultaneous multi-axis operations. Program the latest machines with milling, drilling, turning, and 5-axis capabilities. Using a graphical display, the Synchronization Manager provides interactive control for machining sequences across multiple channels. Keeping track of the in-process state of the workpiece is a critical component of effective mill turning. NXCAM automatically generates an in-process workpiece or an IPW to provide seamless transfer of workpiece configurations between milling and turning. More advanced programming capabilities is the 3 to 5 axis toolpath conversion. Automatically adjust tool axis or retracts to avoid holder collisions. It enables the use of shorter tools which reduces vibration and chatter. Available for 3-axis finishing and roughing operations, and is an ideal strategy for high-speed milling of moulds and dies with deep cavities and fine fixtures next to tall walls. This toolpath resembles a traditional fixed axis toolpath. The system constantly looks ahead for tool holder collision. When none is encountered, a 3-axis toolpath is output. When a potential collision is anticipated, the tool axis is gradually tilted away from the collision area, resulting in a 5-axis toolpath. NXCAM has been established in 5-axis capabilities longer than most other systems. For complex parts, typically for aerospace and power generation parts or medtech parts, NX offers a highly flexible approach and a range of tool-axis control options for 5-axis machining. For example, when programming a part with multiple pockets with drafted walls, it is just necessary to select the pocket floor once and the system can create the finishing toolpaths for the walls. Variable axis profiling automatically machines complex walls by simply picking the floor geometry. C-level machining with tilted tool can reduce tool deflection for better surface finish, and streamline toolpath is an ideal cutting strategy for multi-axis high-speed machining. NX offers specialized 5-axis NC programming operations for complex multi-bladed rotational parts such as blisks and impellers for aero engines, turbo machinery and power generation equipment. These complex parts can feature curved blades with undercuts and multiple splitters. Reduce programming time by as much as 50%. Many machine shops embrace new innovative technologies such as robotics technology to gain a competitive edge. Advanced feature-based machining provides extra value in programming automation. In addition, capturing and reusing your knowledge is a powerful way to increase efficiency. So out in industry we can see savings of up to 90% on programming time when using feature-based machining. There's a huge increase in efficiency by capturing and reusing proven machining processes, and you can achieve faster repeatable NC programming requiring less expertise. Feature-based machining is a great example of programming automation that can lead to greatly reduced programming times. NXCAM can recognize a wide range of machining features on a 3D model. This technology can automatically select and build the machining operations for those recognized machining features. This system allows for toolpath and tool change optimization prior to final output. So we can see here the automated process where the features are recognized, the operations selected, the toolpath is generated and optimized, and then the manufacturing output at the end. Feature-based machining and the ability to recognize machining features in a part model. We can also look at an NX CAD model and read product and manufacturing information, or PMI, that's been added by the designer as the 3D model annotation. We can look for surface finish, dimensional and positioning tolerances as data that could affect the selection of the machining process and tools. For example, a different level of tolerance could mean that we need to select a different machining method, perhaps extra operation. NXCAM provides integrated post-processor and simulation which can minimize the setup time and ensure error-free production on the shop floor. So we can see here that we can easily generate machine-specific programs validate processes using a digital twin of your machine setup, and quickly ramp up production. The simplest level of simulation that all CAM systems offer is toolpath simulation, usually with material removal from the stock shape but no representation of the machine and its motion. Often referred to as a toolpath verification, it's driven from an internal toolpath in most cases. The most CAM systems today will offer a machine tool simulation where we can see the part, the tool and the 3D model of the machine tool moving. Impressive and more interesting. In most cases, this is still driven in the CAM system from the internal toolpath data before it has been through the post-processing stage. In NXCAM, when we need a machine tool simulation in the CAM session, we run the operation set through the correct post-processor on the fly and use the G and M codes to drive the motion of the 3D machine tool model in NXCAM. We call this G-code driven machine tool simulation. It has to be a close representation of what the real machine will do with the machining operations because it's driven from posted code and not the standard NC code. NX provides advanced CAD tools that can be used by the NC programmer for everything from modeling new parts to creating setup drawings directly from 3D model data. For manufacturing, NX offers special applications alongside CAM, including tool design and inspection programming modules. Siemens also provides a complete part manufacturing solution to suit your needs. So to summarise, we have one system across all the operations, CAD for part model preparation, tooling and fixture design, CMM inspection programming, scalable to full part manufacturing solution. So now I'll pass you over to Tobias and he'll run through a demo of Productivity Plus within NX.
Hello. I'm Tobias from Janus Engineering, Germany. I want to show you the NX RSP Plus software or NXCAM. NX RSP Plus is an integration of the Renishaw Productivity Plus software for Siemens NXCAM, so that you can use Renishaw probing operations directly from your CAM program. To use the software, you just have to create a probing operation, just like any other operation in NX. You select the template and the operation subtype. Then you have to define a tool, a geometry, and that's it. So this is my operation, my Renishaw operation. And as you can see here, I have just created a probing tool. I have modeled a parametric one. You can also use a 3D tool if you want, but for me this is okay. So to open the operation, just double click it like any other operation, and then you will have this dialog here, where you can change the tool, geometry and program again, generate the toolpath and start the toolpath visualization, and you can go to user parameters. So this is the main dialog of the NX RSP Plus software. Here you define your probing process. Here in the center of the screen, this empty part will later be a tree view, just like the operation navigator from NX of your current probing program. On the left-hand side, you have the so-called probing statements. These are divided into categories like measured statements, the ones in red, and constructed statements. These are some special statements to do some measuring, and logical statements like if then else clauses or machine updates. On the right hand side there are some add-on modules. They are called custom macros, like the L-probe measurement macro, or special tool updates or reporting features. So to create a simple measured point, just click on this statement here. Then you have to type in a name. We'll see that in a second. Then you can pick your position in the geometry and define the approach direction, and you will directly see the toolpath of the operation. So this is how the toolpath will look like if you hit the generate button of the operation. You can also add some other settings like the approach distance. If you want to use a stock, then you can check this box and enter the value here. And as you have seen, if you hover the UI or any control here in this dialog, then you will get a little help text and an image that describes the function. So if I click OK to close the dialog, then you see the first part of the program. It created a measured point, and that is the name I mentioned. And it automatically created a so-called inspection cycle. An inspection cycle is an element where you can define default values like standoff and over travel distance that will be used in any measured statement that is placed below this inspection cycle. You can also define the default tolerances that will be used. You can override those tolerances in every statement again if you want to. So this is how you create a measured point. If you want to, for example, create a measured plane, just select this button. A measured plane is defined by 3 points. Also pick them in the geometry, like a point on surface here. And then you will see the toolpath again of this measured plane. If I click OK, then I see my measured plane here. So now, as I have created some measured statements, I want to do something with the values that come out of those measuring operations. For example, I want to check a value, for example, the z coordinate of this measured point. Then I can use a logical statement like this if condition. If I click on the if condition, then I have to select an operator, equals, lesser, greater, not equals, and so on, and the left-hand side and right-hand side of this condition. I can either type in the commands or click on this button to pick something from the program. So here in this drop-down menu, I get every probing operation from my current chem part that is listed before the current operation in the program view. So everything that has been measured before the current operation and the current operation itself. If I click on the current operation, my initial probing _1, then I get my 2 measured statements and I can see the properties of those statements. Every statement has different properties, like a point has a position and a plane has a center point and a normal vector, for example. And I can use all those values directly in my program. If I select one, then it shows me the toolpath and the point on the geometry that I have selected before. So now I click on OK, and then I get this expression here. I can also do some calculations here, like adding a tolerance value, for example. And then I have to select the the other side of the condition. I can go to the picker menu again to select something from the program, or I can enter the value directly. For example, if I want to check if the position Z coordinate is at, for example, 100, then I can enter it, and in my probing tree I get this if condition, and now I have to select what should happen if this condition is met. So, for example, what could happen? We could update a tool, for example, a tool diameter, a tool length. We could update a coordinate system in its position or rotation, or we could add a go-to command to jump somewhere else in the program, or we could simply output a report. For example, to update a tool, I go to this NC update statement, select update tool length. Then I just have to select my tool I want to update. These are all the tools that are used in the current CAM program. For example, this milling tool here. And then I just have to select the feature that should be used to update the tool. So if I select this point here, that's all I have to do. And the software automatically calculates how the tool should be updated based on the selection in my program here. I don't have to mess around with any machine variables or other references or something like that. I just have to define my statement I want to measure, and then select the tool that should be updated, and with which statement it should be updated. So if I want to report a measurement result, then we can simply add a report here. And in this report, I can select some references, like I want to report any information about my measured point. I want to report any information about my plane. And for example, something from another operation. Let's pick this one. Here is another point. For example, like this. So in the end, when you run this program on the machine, the software will create a text file with all the probing results grouped by those report statements. So you can define some more of those elements in your program, anywhere in your program. It doesn't have to be in the last operation. It can be anywhere. And the result file will be grouped into those reporting sections with the different information you select inside those statements. So if I close the dialog and generate the toolpath, then you can see the toolpath we have seen in the screen before now is a valid NX toolpath. You can also do the verification here. Toolpath verify, and hit the play button. So it's a little bit slow. So this is how you create a basic probing operation. So a little bit better example is, for example, a part alignment operation I can show you. So you can also save all of those probing operations in a template and reuse them in another program. So for example, you could save this part alignment operation in your template file, and then you can import this operation in any CAM program, and you just have to select some points and you get all the logic and the structure of the probing operation automatically. So to create this part alignment, I have defined some elements here. At first, I measure this line here on the side of the blank part to get the orientation and around the z-axis. So to do this, I've just selected 2 points and defined how many measured points should be used. In this case, I have 4 points, one here, one here, one here, and one in the end. And this is enough information to directly update the Z rotation of the coordinate system I'm using for the milling operation after this operation. So here I have selected the rotation update and I just created a measured line. And the system automatically shows I can use this statement only to update around the z-axis. So now I have aligned the coordinate system around the z-axis. Now I want to adjust the position of the coordinate system in the xy plane. To do this, I have measured 4 points on the blank part. So you can see here's an offset because the blank part is hidden. So I've measured one on this side, one on the other side, 1 point in the y direction, positive, and 1 point in the negative y direction. And now I have 4 points I can use to calculate the center point of my blank part. To do this, I use such a constructed statement. So this is one of those blue statements here. A constructed statement is a calculated geometry element that is displayed as a green dotted line here. I hope you can see it a little bit. And these statements can be used to calculate some values like the distance between those 2 points or the center point of this between those 2 points. And this center point is what we use in the update for the position of the coordinate system later. We do this also for the y-axis. I have to go to wireframe, and then you see the dotted line here. And in the end, I use again such an NC update statement, and now I select the position update method and select my coordinate system and my constructed line. I'll go back to the picker. This is the same selection interface here. I select the X line, and in the second update I've selected the Y line and checked the use Y coordinate checkbox, and then the coordinate system is updated in its position to be placed exactly in the middle of the blank part. So the next operation is a milling operation, and here the coordinate system is used that we just updated based on the blank. And then the process continues with the roughing operation of this cylinder. And then we measure the cylinder, this hole. sorry, deselected. So here you can see the toolpath. This is how a measured circle is defined. You select the center of the circle and define the inspection depth and the nominal diameter. And you can also say if it should be measured with 4 points or with 3 points. And in this case, we directly update the tool that will be used for the next cut in this hole based on the measurement. So the first operation, this roughing operation, we did with an offset. Then we measured it and updated the tool, do the test cut, and then we measure it again. So like this, it's basically the same, a measured circle. And here we do some additional checks. So we check if the center point of this hole is transformed in X or Y direction by more than 0.02 millimeters. And if it's the case, we will stop the program and output a comment. It's a position error greater than 0.02 millimeters. So if that's not the case, then we just update the tool again without an offset, and then we can do the finishing operation. So the rest of the part should be machined based on the center point of all those 4 holes. So that is why we measure them again and create the center point with the constructed lines again. So here you can see how you can use those constructed statements. So we measure all the 4 holes here. And then I use the constructed line to get the center point of those 2 holes and the center point of those 2 holes. And then I connect the center points of those 2 constructed lines again to get the center point of all 4 cylinders. And then I just have to update the coordinate system again to be positioned in X and Y to the center point of this constructed line. So in the end, then we measure a tilting error based on 3 points and machine those 2 holes here. And in the end, they are measured again, and the last operation should contain some quality measurements. The circles are measured again, and a report is created. So this is a simple example of how you can use this Renishaw Productivity Plus inside NX. One thing I forgot to mention is we have a little status indicator here on top. So if this group is collapsed, then everything is okay. If you forget to enter some information in one of the statements, or if there's a logical error in what you have defined here, then you will get a message on top here. For example, if I define a diameter with 0, then you get an error message that the diameter of this circle should be at least 9 millimeters because of the standoff distance that is defined in the inspection cycle and the stylus diameter. So the system helps you to not make any mistakes here defining those probing statements. So in the end, when let me just quickly generate the operations. In the end, you can do a post-processor run, and while the post-processor is running, or before the post-processor runs, it checks the operations again, all the probing operations, and if there is a validation problem, then there will be a message and you won't get an NC code output. So, for example, just hit post-process, select one of the machines, and now we get an error, and that is why this is the validation, and now we don't get an NC code output. So the error was I have an empty probing operation here. As you can see, nothing is defined here. So I either have to put this into the unused items or simply delete it because I don't need it. So now if I hit post process again, so another error is my test operation I've created first. If I put this to unused and hit post process again, then I should get valid output. So now you can see everything is validated again, all properties are checked, and if there are some problems, then you will get either a message box that says that there's a problem, or you get some details here in this information window. Here you can see the NC code. In this case, we have defined some comments here that you can see where the Renishaw part starts and stops. So this is the output of the Renishaw post-processor. So you create the Renishaw program in NXCAM machine independent, and you can use different post-processors for different machines on the same program to get the output for the different machines or different controls. So this is a huge benefit of the Productivity Plus tool in NX. So I think that's it for me now, and I want to hand back to Donna.
Thank you, Tobias, for a brilliant demo and for your participation today. If anyone has any questions, please email me at donna@kaizenplm.ie or email support@kaizenplm.ie. I appreciate you all for joining me today. It's been great. I hope you're all staying safe and staying positive. So I look forward to working with you all in the future. And again, if you have any questions, please do not hesitate in getting in contact with myself or any of the team at Kaizen. Thank you.